Episode 5 of the Torque Factor podcast is here, and I'm your host, Scott Brown. This is a place where we discuss all things moving the automotive service industry forward, focusing on expanding knowledge and awareness around tools, equipment, education, and industry trends. Well, I'm very excited to bring you this episode, and if you're interested in learning a whole lot about OBD and why things work the way they work today, and want to know what the future is going to look like, then get ready for what I believe is an awesome discussion. I was very fortunate to sit down and talk with OBD engineer Bob Gruszczynski, who recently retired from Volkswagen Group of America. Bob is a communications expert and has been involved and still is with OBD at many levels. He and I go deep on a number of topics, including monitors, in-use performance testing, positive kinetic energy, electric vehicles, powertrain, body, and chassis codes, and how DTCs in the near future could get a little confusing, generic OBD and OEM software, unified diagnostic services, 3-byte DTCs, regulations, and more. As you can tell, we're about to cover a lot of ground, and we would love to hear your questions, so please let us know how we can help. VehicleServicePros.com is a trusted online resource for vehicle service and repair information, fleet maintenance management, and the latest products for servicing America's fleet of vehicles. It is the official website of professional tool and equipment news, fleet maintenance, and professional distributor magazines. VehicleServicePros.com is on the pulse of the industry, sharing new technology, the latest product information, and market trends to keep our readers in the know-how. Okay, that brings us to our recall segment. First up is NHTSA Recall 19V as in Victor -298, and it covers approximately 94,000 Acura and Honda vehicles. This recall covers certain 2018 and 2019 models, including the MDX, RLX, TLX, Odyssey, Pilot, and Ridgeline. What has happened here is that due to a production line expansion, the OEM timing belt manufacturer ended up with a manufacturing flaw which resulted in a deficiency of the timing belt structure. This defect can result in a rough-running engine, DTCs P0341 and or P0369, or complete failure of the belt, resulting in an engine stall along with engine damage. Our second NHTSA recall is 20V as in Victor -144, affecting over 121,000 Volvo vehicles. The recall covers 2019 and 2020 S60, CX60, XC40, S90L, V90, V90cc, XC90, V60cc, and V60. These vehicles all possess a deficiency in the automated emergency braking system. Volvo has identified that the active safety domain master microprocessor cannot properly interpret the temperature values from the internal memory, which leads to a low confidence value signal from the forward-facing camera. When this occurs, the AEB functionality is degraded. Recalls are important, and it's sound recommended best practice to run the VIN number through the NHTSA website on vehicles passing through your service bays. Now, traditionally with the Torque Factor podcast, we would have a case study segment about this time. But due to the length of the discussion we had on OBD with our featured guest, Bob Gruszczynski, we're going to dive right into that discussion. So let's have a listen. So today, folks, we have on the call Bob Gruszczynski, recently retired communication expert from Volkswagen Group of America. And he's here to join me to talk about some OBD stuff and whatever else comes to the table here. So welcome to the call, Bob.
Thank you very much, Scott. Good to be here. Thanks for having me.
Great. So this is awesome. Just to give a little bit of background, I did look at your LinkedIn page, and I see that you've got quite a few attributions to SAE OBD stuff. So you're involved with the J1962 Task Force, the J1978 OBD2 Scan Tool Task Force, You're co-author on a 1699-2 that was a test cases for OBD2 scan tools and I&M test equipment. And also author of the J1699-4 OBD2 Communications Anomaly List Information Report. That sounds very interesting. And the J3138 Diagnostic Link Connector Security Recommended Practice. And I see a lot of activity in the security space. So perhaps we'll talk a little bit about that. So that's just a little bit of background, but can you just give me a little, or give our audience a little more perspective on your background and what you're involved with, on the electronic side, and what impact you've had over the years leading us into the OBD2 era?
Sure. So I'm kind of an old guy. Started in the early 70s in the data communication area over the airwaves. Graduated to computers, designed printers and test stands and all kinds of fun stuff before I got in the auto industry. I started in the auto industry in late 1989 working for Ford Motor Company, writing powertrain control software for those guys. I'm kind of an embedded microcontroller software guy. That's kind of my real background. And it kind of plays into a lot of the OBD stuff that we'll be talking about later because of some of the requirements that CARB has coming up. But then I transitioned into strictly OBD. I haven't written a line of code in almost 20 years now. Back in the early 2000s when I left Ford and went to work for a contract company called IEV Automotive Engineering and picked up a contract with Volkswagen to do their OBD communication testing and other consulting activities, and finally got hired into their company and been there ever since doing OBD, and kind of ended up in the middle of it. As you can see from my SAE background, I've gone anywhere from, chairmanship of minor committees to the chairmanship of the EE Diagnostic Committee, which oversees all the data communication items for OBD. Excellent. So, and you're still pretty heavily involved, even though you're retired, you're pretty heavily involved with OBD. Committees, correct? Yeah. So I kind of promised SAE that I would see through the next California Air Resources Board OBD rulemaking coming up this fall and kind of help provide guidance to some of the activities. As I mentioned, they have a lot of requirements coming up, and we're trying to balance that with what it takes to run an engine in an engine controller. I think we'll talk a little bit about that later on too. So sure. Okay. Well, great. Thanks for that background. So just one other little piece of information. I know that when we had talked earlier, you had mentioned that you worked for another company called Visteon. And so what, can you give me a little insight as to what microcontroller work you may have been working on back then that actually would have been on a vehicle in the past? Sure. So I ended up working for Ford of England. I went across to England as a Ford employee for a couple of years. And when I came back, they had spun off my division into Visteon. And I'm sure that most of your listeners know about the Visteon Ford split back, similar to GM and Delphi. And when I was at Visteon, still writing powertrain control software, a couple of my guys, got into a new scheme for doing misfire detection. And so we worked on that and was really great. I mean, there's a ton of data. I mean, misfire requires just a huge amount of data. And by the time we got done with their original models, the controller that we were using for Ford vehicles at the time got overwhelmed by this amount of data. And my job as part of that team was to modify the software or write software that reduced the amount of CPU time that the data would require crunching. And so I did that. And then at the end of the day, we ended up with a U.S. patent. And that software and that misfire scheme still runs today in basically all Ford vehicles. So yeah, that's fun stuff. That's awesome. So just one of the things. So it sounds like you were the optimizer, right? The code optimizer. So they had this bloated code. They got the job done on what their objectives were, but
then you came behind and had to really kind of optimize it and make sure that you had the least amount of overhead needed to run it. So what kind of optimization number can you tell me that you were able to achieve?
Yeah, so basically when they started modeling this on a PC, of course, your PC is compared to a vehicle as unlimited resources. Most vehicle microcontrollers in the ECU are about 2 megabytes of flash, not gigabytes, but megabytes, and about 64K of RAM, 64 kilobytes of RAM, not gigabytes of RAM either. And so we have to fit all that stuff inside. And of course, the processors in an automotive environment run about 100 megahertz, not gigahertz speeds either. And so that slows things down a lot. So when we moved from the PC platform to the vehicle platform, their little algorithm took up about 95% of the CPU processing power in the engine controller. And my optimization cut it down to about 5%.
Wow.
And that's what made it feasible for being in a vehicle. So.
Yeah. That's very interesting. Yeah, thank you for sharing that. That's very, very cool. So yeah, that brings us kind of into the OBD stuff. I remember years ago when I first got in this industry was early 80s, and I remember my father-in-law was reading a New York Times article or something. He says, "Hey, do you know that these car manufacturers are going to have some kind of sensors in the cylinder to tell when it's going to misfire?" And I'm thinking, oh my gosh, what the heck is that all about? So yeah, it's amazing what they can do with software and inferencing and measuring and analytics and everything else. Way above my processing level, but truly appreciative. So when we talk about OBD, or OBD2, the original goals were to basically help with diagnostics and identify emission noncompliance, right, with a vehicle and turn the mill on. So when did you get involved with the OBD with the regulation support?
Yeah, so when Visteon got spun off, they had a good time, and then they fell onto some hard times. And at that point, around 2003, 2004, I decided that my best bet would not be working for them anymore. And so I went into the open market and went to work for a consulting company called IEV Automotive Engineering, which I found out that was a 51% ownership by Volkswagen. And Volkswagen at that time didn't have a lot of presence in the U.S. in the OBD world. The German guys were coming over a lot, and it was very expensive. And so they hired IEV, and IEV looked at me and said, "Hey, you have SAE experience because of some work that I had done before, and you have powertrain experience, and you know about OBD, so why don't you go do this contract?" And Volkswagen liked the fact that I was doing it and how I was doing it, and ended up extending me an offer, and I started working for them full-time in 2008.
Okay, so 2008, that's around the time that the CAN stuff came into the world, right?
Yes, the CAN stuff, but up until then, there was still a lot of legacy protocols, J1850, the K-line stuff, which is ISO 9141, and 14230, which I worked with extensively at Volkswagen. A lot of vehicles were still running that. There was still a lot of issues with tool interaction. That's when I got involved in inspection maintenance, IM program interface and liaison with the different states, and working through issues with vehicles communicating with IM stations.
Okay, and so based on the what you were working on then and the focus and the goals, how would you classify the goals, the objectives, being able to meet the objectives and what we've got in the marketplace today? Right.
So the regulation, it's California regulation. The final numbers are 1968.2 that lay out the emissions, requirements by CARB. Basically, the purpose of OBD2 is to use onboard computers and monitor emission systems in use for the actual life of the vehicle, and will be capable of detecting malfunctions of the monitored emission systems and notifying the vehicle operator when a malfunction occurs, so that they can take it in and have the vehicle repaired, basically. So there's a whole 221 pages of things that vehicle manufacturers have to monitor, basically how they have to monitor it, the best way of doing it, best engineering practices, and things like that. And so those are the objectives. And so the auto manufacturers, we complained, that, oh, this isn't feasible, this is hard, very expensive. But I think we came up with a good compromise. And I think, up until this point, we've done a very good job of cleaning up automotive exhaust emissions. And going into the future, I know that they've reduced the standards again, and there will be some more upheaval and more things coming. But basically, I think vehicles are pretty clean these days.
Yeah, it is. It is amazing how clean an automobile and how well it runs. I mean, it just amazes me looking at an automobile and how many microcontrollers are on board and how that vehicle starts and runs properly every day for the most part, and does it for hundreds of thousands of miles. I mean, it's absolutely amazing. It's like a science experiment on wheels that actually work. So
right.
So that's
my thing is, the problem is the OEMs have multiple objectives that are mutually exclusive, right? Because you have to beat emissions and drivability and fuel economy. Those are all hard to meet all at the same time, right?
Yeah. And I would like to also express that I think the industry really needs to think guys like you and Paul Baltusas, because I was at an OBD conference probably about 5 years ago here in Southern California. And I remember Paul gave a presentation on kind of the history of OBD, and it was funny because he was pretty animated and he had a really good storyline. So one of them was that the day that they rolled out the OBD standard with the mill light and all that, he said he made some comment about they were so worried about lighting up the foothills of Southern California with this orange glow of all the check engine lights that were going to be illuminating. But more importantly, what he was also talking about is that when CARB kind of came to the table and said, oh, you guys are going to be monitoring all this, and they wanted to run wires from every sensor up to this data port connector. And he was expressing that, hey, we had to tell them the better way to actually approach it. So does that sound familiar?
It does indeed. And it carries over to today, because the future requirements, we've done a lot of work and still working. In fact, I have a meeting after this today with CARB and the J1979 team. CARB, everybody thinks that the car is a computer on wheels, which it basically is, but automotive electronics is so much different than commercial electronics, and you can't have a gigabyte of flash and a gigabyte of RAM and things running at a gigabyte speed in a vehicle and expect it to run through minus 40 to 125 degrees C. And so the processors are limited, and we only have a certain amount of space to store data and still, run the engine and run OBD. So, it's really a difficult balancing act.
Yeah. So, and I, again, I can totally appreciate, the experts bringing reality to the table. So, so let's just talk a little bit about another topic here, the in-use performance testing. I know you touched on it just a little bit, but that is mode 9. Is that correct?
Yes, that's correct. Info type 8 is for spark ignition engines, and info type B is for compression ignition engines. And basically, it's a monitor for all the major systems in the vehicle. There is a requirement in the regulation for the ratio between the amount of times that the engine or the powertrain system is active and the number of times the monitor can run. If that ratio falls below a certain number, vehicle will fail inspections and other things. And so That's one way that CARB keeps an eye on how the vehicle's running. We actually have to pull vehicles after a certain amount of time out of the fleet, and actually run tests on those to make sure that the ratios are correct and that the monitors are running properly.
Okay, so let's talk about how the technician can benefit from or leverage the in-use performance testing, or what diagnostic value does the in-use performance testing bring to the technician?
Yeah, that's a really good question, Scott, and it's kind of a difficult one to answer in general, but basically you have a number of counters that say the counters are split up into the conditions encountered, which means that the vehicles run through a set of conditions where the monitors should run, and then the number of completion counts. And then there's an overall ignition counter that tells you how many times the vehicle's been operated. And so if you can get an insight of, every vehicle manufacturer kind of monitors things a different way, so it's kind of different between all OEMs. But if you can get a feel for, you work on a number of vehicles. I know guys work on Dodges or Audis or whatever. You can kind of get a feel for what those ratios, and if you go out and run the vehicle around, whether a counter counts up or not. One of the tests that we have to do after production is actually take a vehicle out on the road and make sure that these counters are operating correctly. So you can take the vehicle out on the road. You can watch the counters count up after a certain drive cycle. And if the counters don't count up, you go, oh, wait a minute, this monitor hasn't run. What do I do now? How can I get back in and see if there's a problem that's preventing this counter from running, or this monitor from running?
Okay, got it. So I have been looking at quite a few vehicles and trying to pull the Mode 9 information, and what I've observed is I can see the conditions that were met. So say that number is 12,000. And then I can see when the monitor has run, and a lot of times that number is actually higher than the conditions. And I interpret that because it's basically, it met the conditions and it ran the diagnostic multiple times during that condition. That's
correct. Yep.
Okay. All right. Yep. So that's pretty, I think that kind of gives you a little bit of a perspective on historically what's been going on with the car. But here's one of the things that I've observed recently. And I was holding a little tiny, kind of a micro class here in the shop, and we were going over some stuff, and we had a vehicle, and it was a Ford, and it needed a software update. There was a new calibration update from the OEM. So we looked at all the Mode 9 info, recorded it, and we made the calibration change, and guess what? It basically reset all of that in-use performance data, which kind of blew me away. I thought, wow, it's weird. It lost all the history. So is that the way it's supposed to work?
Yeah, it's allowed to reset. The regulation specifically states that those values are allowed to be reset on a reflash or a calibration update. So yeah, that can happen.
Okay. All right. So that's pretty interesting. So I did also notice on some of the new cars, and I had a 2020 model year vehicle I was writing an article on, and it was another Ford product. And I went in and looked at the Mode 9 info, and I found some additional data in there. Some things about the vehicle. It had to do with the mass and how much fuel the vehicle was consuming, or they were energy-driven parameters. So, and I know that those are new requirements that were put in place a few years ago, and now I think they're required on current model year vehicles. What can you tell me about that data?
Yeah, that's correct. So in 2016, CARB added vehicle operation data to the required list of parameters that need to come out of the vehicle. It's not OBD data per se, but they figured that since we're reporting, J1979 is kind of a catch-all, the same as J2012. It started out as just OBD data, but now They've added all this extra data, and I think we can talk about some of the UDS stuff, but basically right now, they have vehicle operation data, and it's used for a couple of different purposes. One is essentially to validate their policy decisions, to make sure that they think they're doing the right thing. And when they gather this data from the vehicle, they have all these statistical charts and things that they do back home that tells them whether or not they're doing the right thing. And then the second part is they started with heavy duty, but this got into J1979 because heavy duty manufacturers of late have been allowed to use other than J1939 data reporting methodologies. They can use ISO 15765 and J1979. And this data is greenhouse gas and NOx binning data. And that's going to come to light duty very soon also. And basically what it is, it's kind of a pseudo PEMS data gathering. You can't really do perfect PEMS testing, but with this data, you can get a thumbnail as to whether or not the car is or truck is, polluting more or doing other things. So basically that's all the new data that's come into J1979 and quote unquote OBD.
Okay, and you like to lay a lot of terms out because you're normally talking to the higher level folks that run in your same circles. But one of the things you mentioned, PEMS testing. So I believe that's portable emission measurement system?
Yes, that's correct.
Okay.
Sorry.
Right.
Yeah.
And so I've seen those on vehicles, or I've seen people using those where they've got basically a gas bench and other things processing data, and they've got a probe actually collecting gas out of the tailpipe. But the PEMS, this is basically measuring the mass of fuel being used over the movement of the kinetic energy being used to move that vehicle, correct?
Yeah. Those vehicle operation data pieces are basically to monitor how a vehicle is being operated. Okay. So it's really funny. We had this huge blow up at a CARB meeting over the positive kinetic energy function. It's like, well, they gave us a formula. They've been running this formula on their PCs and doing all kinds of modeling and stuff. And we're like, this is not an energy calculation because there's no mass. They were like, yes, we understand that, but we'll use some of this other fuel economy stuff to infer how you're using the vehicle. Because if you just get a PKE number, a positive kinetic energy number, it would be like taking your F-150, two F-150s, and going up a hill, right? So you're gaining kinetic energy going up the hill. But one of those F-150s is dragging a D6 bulldozer behind it, and the other one I have my lunch pail in the front seat. And you can't tell the difference between, using this calculation, you can't tell the difference between the two trucks and how much energy they're actually using until you add in the fuel factor that comes out of the vehicle. So, we had a huge amount of discussion about this, and we ended up doing it the way CARB wanted us to, and you can infer that information from all this data. But basically, that's one piece where they're inferring vehicle usage. The other piece is the grid energy. There's a whole bunch of grid energy things. They have a charge depleting operation with the engine on, with the engine off, charge increasing operation. Just an amazing amount of stuff, talking about the battery energy and how much energy you draw from the grid, because the grid is not clean either. Is that correct?
Yeah, that is correct.
So they're looking at all forms of pollution now, and they're trying to figure out how the grid energy that you pump into your car overnight is affecting the air quality from that side. So yeah, they're doing a lot of work.
Yeah, and that's probably another deeper subject for later, because I do drive an electric vehicle. Actually, I also produce my own electricity or my own fuel at home. And so I'm not sure how they could factor that in, because a charging event, I don't know if they would be able to factor in where it's getting charged and what the ultimate source of that energy was. But that sounds like a very, very deep, deep subject in itself. So you mentioned 2016 was when CARB came and approved or made that requirement. So what was that effective on? What model year vehicles?
2019 and beyond.
Okay, so 2019 and beyond. So for the technicians listening, they want to look at the Mode 9 data, and they're starting to see some new stuff that you just heard, where that came from. And so that's very interesting. So we'll see how that data plays into the into the world, and whether or not that was actually a smart move, or whether they need to do modifications or what have you. So and as we talk about, in the early end or the early beginning of this call, we talked about the overhead right inside that processor, the number of processors of memory, the clock speed of the processor. When you add more and more stuff, it's moving those requirements up. And you mentioned UDS, and I've seen this term many times. Let's just go into that. And I think that that's something that's going to extend the current OBD, because we have some limitations that are actually starting to hit. Right, we're hitting some ceilings on what the original architecture of OBD was, and so can we talk a little bit about that?
Yeah, we sure can. So UDS stands for Unified Diagnostic Services. And Unified Diagnostic Services are actually defined in an ISO standard, ISO 14229, which is kind of an enhancement of J1979. J1979 was OBD specific. Now, your technicians are probably familiar with ISO 14229 or UDS, because many vehicle manufacturers, but not all, use UDS services for enhanced diagnostics. So any enhanced diagnostic functions that you use through either an OEM specific tool or an enhanced diagnostic tool that you've purchased from Bosch or Snap-on is utilizing UDS services. Just a quick background, OBD services are service 1 through service F. Currently, we only use service 1 through service A. Service B through service F are still reserved for future use if we decide to do that. There's been some discussion about that. UDS services start at hex 10. So those of you who are hex knowledgeable, 0 through F are 1 through 15, or 0 through 15 decimal. And then in hex, you flip over to 10, just like you would from 9 to 10, you flip over from F to 10. So anything above F is a UDS service. And so UDS services run from service 10 and above. And I can get into a little bit later what services are equivalent to service 1 through service F in UDS. But basically, a little more background. Let's see, UDS, we have talked about running out of DTC space, especially powertrain DTCs, with the new technologies coming on board with hybrid and resurgence of compression ignition and some other technologies. We're running out of powertrain DTC space. So there's been a lot of talk about how we're going to survive without too much more space in powertrain DTC. So your technicians may have noticed a change already. About 2 years ago in J2012, we stopped allocating the sub areas within DTCs. It used to be the area next to P used to be a vehicle system area. So, P01, P02 used to be air, fuel, spark. We've abandoned that to start with about 2 years ago. We just started filling in codes wherever there were spaces. Eventually, there's a possibility that we're going to start putting powertrain codes in the B, C, and U area, just because UDS may not come fully in time for us to salvage the PBUC structure. So
wow, that is interesting. I guess that's the old rule of thumb is it's always been that way. No, it will always be changing, right? Because
yeah.
That can be confusing because if you live by those old rules, but the air, fuel, and spark related DTCs, and then all of a sudden you come across something that's totally out in left field. Now you can kind of gain some perspective on why this is happening. And now you see B codes, you see powertrain codes showing up in the B space because of these limitations and timing, right? So the UDS is basically kind of a next generation of process or handling these extra loads.
Yeah. So in body and chassis, you're already allowed to use 3-byte DTCs. So your technicians may be familiar with having a failure type byte, where the failure type byte actually gives you more information about where things have fallen apart during your testing. CARB does not allow it. CARB does not allow 3-byte DTCs. They only allow the 2-byte DTC space. So that's why we keep chewing up the P codes fairly quickly. But basically, there's a whole lot more information. There's probably 100 failure type bytes that are far more descriptive than the standard SAE DTC. The standard DTC, SAE DTC, were defined early on basically by CARB regulation. They wanted to do circuit checks. And so the easiest way to do circuit checks and other things were to have what we called the big five, which was circuit open, circuit high, circuit low, intermittent erratic, and the last one is, let me double check here, performance. And so basically, or range, and then there was range performance. So basically, in the old days, a sensor went into the ECM by some form, mostly by hard wire, as you mentioned before, and is read by an A to D converter. And so it was always difficult to determine whether there was an open circuit or a short circuit based on how the internals of the ECU worked. So the only thing we could tell was that the signal was always high, the signal was always low, and it was upon the technician and the service literature to figure out whether there was a short circuit or an open circuit somewhere in the line, wiring failure of some sort. Because we know that wiring failures are one of the biggest problems that we run into. But basically, the failure type bike opens up a complete new horizon of being able to pinpoint problem failures in a vehicle. And so that was the impetus behind trying to get CARB to allow UDS services, or at least 3-byte DTCs. We started that process in 2014 working with CARB, and they dragged their feet for a while. We dragged our feet for a while, and there was a lot of interesting back and forth, and there still is. Like I say, I have a meeting at 11:30 today with CARB, because we're still finalizing some of the details. We had to update the UDS services. We had to go to ISO and ask them to update UDS services to accommodate some of the new requirements that CARB is putting into place for their UDS service request. So
interesting. So it blows me away that they are pushing back on the 3-byte DTC usage. Why? What? I mean, for us on the street, why?
Yeah. So the CARB's all, anytime we try to make a change, and it requires a change to the tool. And so the issue is that they only, they can only purchase so many tools at a time. I mean, that's a big expenditure for that many IM stations and everything else. And it is a burden on the tool manufacturer. I mean, we're all in this together. And, J1978, which I used to be chairman of, was the scan tool document from SAE, J1979. We have to change the vehicles, we have to change the tools, we have to change the regulations. I mean, everything's a change, as you mentioned. And so CARB was always reticent to make a big change because the tool manufacturers would have to make a change, and then they would have to purchase either an upgrade to their current tool set or a new tool set. I'll give you an example. Bar 97, which I'm sure you're way familiar with, was from 1997 and did not get updated until either it was 2012 or 2014. I actually worked with Bureau of Automotive Repair on specifying how that tool, the new OIS system, was supposed to work. But basically, CARB required all vehicles to communicate only over CAN starting in 2008. Unfortunately, you couldn't get a CAN car tested in I&M in California until 2013 because the tools weren't updated to read CAN cars.
Mm-hmm. Wow.
And that's why the 6-year exemption exists in CARB regulations.
Yeah, that's amazing how these rules manifest, right? It was, we just hit a wall. Oh, we'll just write a reg to get us out of it, of that problem. So, yeah, very interesting perspective. So, I mean, that is awesome. And I think, we were just you're talking a little bit about the tools. And so I think I'd like to segue into the fact that, there's a lot of guys out there that use OEM tools, dealers use OEM tools, but a lot of them hide the generic OBD. So how can you explain why that happens to some OEMs?
I'll speak for the OEM that I used to work for is that, they have their own methodology. One of the things that I found interesting changing over from an American car company to a German car company was the philosophy on vehicle repair. In Germany, the methodology is that they have one master technician in a dealership, and he's the master diagnostician, and the rest of the guys are essentially parts changers. He diagnoses the issue and then goes to a guy, okay, replace EGR sensor, replace O2 sensor rear. With the advent of more intelligence and automated tools, basically you'll find, I'm sure that your guys who are familiar with Otis are familiar with the guided functions, guided fault finding and guided functions, which are basically the same thing. Volkswagen Group has basically put their master diagnostician into an automated machine, and you follow the path, right? You follow the path, you click on, you do the step, you click on enter, follow the step, click on enter until you find the problem. That's an issue for a lot of time and materials techs because they've worked on 100,000, Volkswagen Jettas, and so they know that the EGR sensor goes bad, on these cars 90% of the time, right?
Mm.
Or you go to All Data or something like that, and they tell you that, the majority of the cases are this. And they want to go in and change the EGR sensor, and Otis won't let you do that. And so you have to follow the steps and take time to go through the whole thing. And so there's no reason to have generic OBD on board those tools. I know that my boss in Germany and the OBD communication guys were always like, hey, you guys need to put OBD on these tools. And they're like, and we fought tooth and nail to get OBD put in on Otis. And for a long time, that was just not the case. So
yeah.
That's kind of the thing. If you want to segue into Mode 6, especially,
yeah.
Mode 6 data, if you look at OEMs technicians never use Mode 6 data for anything. But your technicians in the field, independent technicians, have found some of that data to be useful. And so, there's always been the petition about, don't get rid of Mode 6 data because it's useful in the field. So Sometimes it can be misleading, but a lot of times I know a lot of technicians myself who have repaired a lot of cars using Mode 6 data.
Yeah, it is a little confusing sometimes to look at, and so it takes some time for you to have a pretty good understanding of what it's telling you. But it is like a report card. I mean, it's showing you statistical values on how the system was tested and where it came out, versus a technician kind of looking at live data trying to figure out how well this sensor is performing, or maybe like the variable valve timing. I had Paul Baltusis on one of these episodes, and we went into the variable valve timing stuff, and it was very enlightening. And he did explain that it is sometimes very difficult to understand what's going on there. But when you drive, you can drive the car and you can actually see it update that data, knowing that it just ran some either performance or some comparative analysis or what have you, and then it gave you where it landed on its test results. It's pretty impressive. So, but again, it is a little overwhelming sometimes if there isn't clear documentation and actually how to implement it or how to use it in the field. So, so anything else you want to share about Mode 6 there?
No, I think that's pretty much it. I mean, Mode 6, like you said, it can be a really good indicator, but sometimes you'll get some false ideas. Some sensor will fall close to the one side or the other during a certain environmental condition, and then you'll look at it during a different environmental condition and it'll be back, and within normal range. But, once you get, like you said, once your technicians get the feel for how a vehicle runs and what the thing is telling you, I think it's easy to weed out the false conditions that you might find.
Mm-hmm. Okay. So I would like to circle back on that, on the in-use performance testing, the stuff that CARB had added. I had another thought that came to mind in another question. So they were talking about looking at where the energy is coming from, especially looking at electrified vehicles, whether it's a hybrid or a completely battery electric vehicle. My understanding is that the battery electric vehicle, essentially, it doesn't have to have an OBD connector. And I'll take one manufacturer specifically, that's Tesla. Tesla does not, anything current, does not have a J1962 data port connector on it. And so therefore, they're not apparently subject to any of the certification tests for emissions. So if CARB continues to move forward and pushing on the, validating where is that energy coming from, how efficient is this vehicle, does that mean that these vehicles will eventually have to have a J1962 port or some sort of data communication port for OBD compliance?
Yes. CARB has been working for a couple of years. CARB staff has been working on a specific data set for battery electric vehicles. And I know several OEMs have been working with them to basically work out the details on what the best, most pertinent information from a battery electric vehicle would be. And my opinion is probably the next reg after this one will have requirement for battery electric vehicles.
Interesting. Okay, so that's going to probably piss off some manufacturers, huh?
Yes,
wow.
I think it will.
Yeah. Okay. That's great. And then I guess one last thought is, is there any attention being given to this big movement of self-driving cars, vehicles with AI, and it could span all over the place. It could be on structured routing, because sometimes if you route a car to a different pathway going to a destination and then coming back, sometimes you can take advantage of terrain and that kind of stuff. Is CARB looking at that, or is that not in their game plan, or is that something that the OEMs might be looking at because that can help them with their fuel their total performance data? Does that make sense?
Yes. Yeah. There have been some discussions regarding routing and those types of things, as you mentioned. vehicle manufacturers are definitely putting their sensor and other data. They're providing information through J2012. That's one of the areas of great expansion within J2012. On the chassis communication and body side, we're getting a lot more DTCs for cameras, sensors, et cetera, from that point. The regulation has not, we haven't talked about too much in the way of regulation in terms of that. The question became whether or not your GPS system or your nav system would become part of OBD because of the routing activity. But right now, there's no movement that I know of in that area. But it has been discussed, and yeah, there's probably a whole nother podcast there, Scott.
Okay. All right, cool. Yeah. So I another thought just came to mind, and we'll try to pick this up on another episode. But just the sheer fact, I review a lot of recalls, and I see some things that are really just kind of blow me away. Talking about the microelectronics development. So they put this brake controller into the marketplace, and 3 years later they realize that when a car experiences a failure mode, this crazy thing happens, and now they have a firmware change, right? But the firmware change requires these 500,000 vehicles to all visit a physical dealer to have them push this firmware into the vehicle. I just look at it and I'm going, oh my God, what if a phone manufacturer out there required every person to come bring their phone to the service center to have the firmware updated on their phone? Where is CARB, or is there any regulation looking at the over-the-air wireless communication?
Yes, there's been a lot of discussion about OTA. Not a lot of conclusive activity yet that I'm aware of. Certainly, there are a number of safety issues involved. I mean, certainly don't want to update the brake controller while you're driving down the road. And those types of things. And also, you touched on cybersecurity. There's always a security aspect to that. So, there's a lot of open issues still surrounding OTA, but it is a very hot topic. It's been discussed in a lot of different areas. And I know that, vehicle manufacturers are using it for non-safety critical systems today. So, it's just a matter of time.
Okay, great. Well, we've covered a wide swath of data and OBD, and I really appreciate, and I think our listeners can really appreciate the information that you shared with us today. I know for myself it was quite enlightening, and so I want to thank you. Thank you, Bob.
Well, thank you for having me, and I hope that I've been somewhat educational to your folks, and maybe we can do this again on different topics. So.
Yep, I certainly look forward to that. So thank you. Due to the COVID-19 pandemic, I have proudly witnessed the pivoting of many of the traditional training organizations where they began delivering webinar-based training. I have attended several sessions over the past few months in my shop along with my staff, and have to say that it's been pretty cool to be able to fill the void. The challenge we've seen recently, though, is that as business begins to rebound, we're finding that attending these live webinars can be a challenge. Fortunately, many of these training providers are recording these sessions and making them available. Take a look at the show notes for links to some of these training opportunities. I would also like to announce that P10 Magazine and Diagnostic Network recently partnered up to launch the Disaster Support User Group on Diagnostic Network. For more information, look to the show notes.
Hello, Newman.
And we'd love to field some of your questions, so please consider emailing us, podcasts@vehicleservicepros.com. Now that brings us to the end of the show, and we hope we're able to bring you some quality content and look forward to future episodes. And we're looking for your feedback, so if you have any questions or comments, please drop them in the mailbag. And please hit the subscribe button to receive notifications on future episodes. Thanks for joining us.